Hi, welcome my first video tutorial on to how to use a BezierCam. BezierCam is a software which I developed for hot wire cutter, hot foam cutters. Later I added some other options for different machines as laser or mills, engravers, but the basics just for wire cutters, and that was the main purpose of the developing this software. There's a few ways how we can generate the program, the G code for our machine, and I will just try to show you in this video tutorial how to do that automatically. But there is some other options which I will go in a depth in the next tutorials. Okay, let's start. This program, when we start, it always trying to get to take a full Windows, full size of the screen. And this version, this compilation is on a Windows. Linux compilation look a bit different. There's a different shape of the buttons and the different colors. Unfortunately, in the Windows, there is not much about the coloring of the UI GUI because the Windows just not allowing that without some modification. I mean, I didn't will to go into a depth of the programming for Windows, but that simple it is. I mean, I'm using the basic GUI to go with. Okay, let's start. To start, we need to generate some material, some virtual material, and I just use the default 400 by the 400 millimeters because I have a machine which exactly is that size. We can go into a machine settings, but as I said, I will explain the settings for laser, plasma, or 3-axis mill engraver in different tutorials. In these tutorials, I will focus on how to use a wire plotter and how to generate for a wire plotter very efficiently, very quick. Few settings. Detection level, I will explain that on a picture. This is only for automatic generation. This option here has G00 speed and G01 speed. Everyone who used the scene coding knows G00 is a rapid move, is a move of the tool. That means in our case it will be a wire in air. That means 3000 millimeters per a minute. And this settings is a G01. That means move in a material, the work move. And for example, I will set a 500 millimeters per a minute speed of the wire in a material. Okay, and let's click OK. Not much change apart of the little cross shown on the start of our material, and material itself is virtual. It is only virtual boundaries which we can see on a grid. That means the grid at this moment is generated exactly on material. We can choose between lines, dots, or mixed grid, which work like that. We can just change a resolution of the grid. At this moment it's a 5 millimeters, but if you want a 1 millimeter, that's how 1 millimeter grid look like. We can just zoom to see it. We can zoom out. We can of course zooming in, zooming out by using a middle button of the exactly a roller of the mouse, or we can use that bar on the bottom of the screen here. Okay, let's put that 5 millimeters, or not 55. Okay, and we can just see the material. We can just switch off because, like I said, it's just a boundaries. Okay, the basic idea was to load some image into a background, and let's select some image. And then when we have the image, when we load the image is always scaled to the height of the material, not the width. That means taking the height. When you click on grid, we can see the image just going out of our virtual material a little bit in a width, but it's starting always from 0, 0. We can of course change that by moving position of the image, and we can select millimeter pixels. At this moment, the image, when we load it, it automatically is rescaled to the height of the material. But when we click millimeter pixels, it will just switch off that automatic rescaling, and it will show us the image in a 1-to-1. That means 1 pixel equal 1 millimeter. That means if this image is pretty small, is at 249 millimeters, and in a height is at 202 millimeters, that's the picture which we're showing now. Of course, we can just manipulate it. make it smaller. Manually we can make it much bigger, and then we can just scale it. Of course, the scaling at this moment is in aspect ratio. We can switch off aspect ratio, and we can just manipulate the width and the height of our picture. Yeah, to match, for example, our material. But then, of course, we know the image will be distorted by that. Yeah. Okay, let's switch off that, and we can just keep aspect ratio, and then it will just back us to a default 1:1, 1 width to 1 height aspect ratio. We can just do some modification of the image, like flip it. We can grayscale it, but at this moment is a black and white. Let's load some color picture maybe. Okay, we have a color picture, is a Kickstarter logo, and as we see is a color. Click grayscale, and it's automatically grayscaled. Okay, let's back to our picture, our elk. In a grayscale, we have a color clipping, and that color clipping is the idea. We can just switch off the white, and we can just manipulate the black to match the background. And now we see the image is almost a shadow of itself. That will just allow us to very efficiently draw image or edit image around that thing. Yeah, and we can of course switch on, switch off the background. Here is just below the coordination parameters, which are just updated. And as of course is a background setting, when we switch that window off, we can just ask it to show it up again. Okay, let's switch over grayscale. We go back to the standard size. Well, let's do it like that. Okay, we have the image in the background, and for our automatic generation, I will show you now how to do that. You're clicking a background to matrix, and that automatically switch off the background. It's still here. We can just switch it on if we like, but it shows us the algorithm detect the edges. And now we can just zoom in and see. I hope that is visible on YouTube. There is a little points, and just a points. There is no lines. Algorithm generated only the edges of the image by the points. Okay, why is that? I will explain a bit later, but this image is a pretty good quality. Is a very sharp edges between black and white. If the edges will be a bit more blurry, then we can use the detection level options. And detection level simply means on a 0 is very close to a black. On a maximum, on a 255, is very close to a white. And by moving this ruler here up and down, we can see how the image is regenerated in a life. And for example, I think that is pretty okay. Resolution options are for as well are very small, or some other images which are not very clear. There is no very clear transition from the white to the black. And that's very important, because we can just go with a higher resolution, which simply means the image, the original 249 by the 202 millimeters, is now virtually rescaled, multiplied by the 7. That means at this moment is something like a few thousand pixels, and each time I'm virtual rescaling that image, I'm doing a Gaussian scale. That means the edges becoming more blurry. As you see, there is not much steps at this moment in this regeneration. Of course, when you go down, there is much less pixels to start with, but 5.6 is normally fine. Scan resolution is used for automatic regeneration. When we click a compute, it will start connecting the points, and this parameter told the algorithm which point to avoid connecting. That means if the point is closer than 0.55 millimeter, it will be just not taken into a calculation. It will be just deleted, and that's it. That means normally you don't need to change this option. If something going wrong, the edges are too close to each other, or the points are too close, you can just start manipulating this parameter lower and higher. That will give you a different outcomes. Okay, we have looking at edge regeneration. Yes. We can click compute, and at this moment algorithm start connecting the points and generating the lines. We have our virtual lines, and at this moment we can create or edit. And now algorithm or the program will ask us how we want to regenerate these lines, because at this moment the lines are only virtual, and to become basic lines for a program to be saved or edited need to be a choose of the mode. Fast mode generating just a lines. That means each line have just 2 points, and these points are just connected in a very long lines. And Bezier mode, it will try to regenerate this shape of that lines with the Beziers. Yeah. Okay, let's start with a fast mode. I will show you the difference between the fast and the Beziers. The fast mode will allow us very quickly just go and ask program to generate the outlines and generate the wire path for this picture. Okay, but with a very simple fast mode, we can just move, scale, or rotate the details. At this moment, of course, we see the detail just going a bit out of our virtual material, and we didn't want to allow that because machine will simply crash into our X or Y limits. And to do that, we can just stretch that. There is a keep aspect as well at this moment, and we can click, move the mouse, and we rescale the image. We can just move our detail to the boundaries of the lower boundaries of our material, and that's it. We cannot delete anything of these lines at this moment because they are connected, and algorithm will take them. If there will be any hole in the between the lines, the algorithm will just simply fail and not regenerate a correct path. I mean, in that fast mode, only edit is possible, like a move. We can rotate that thing, we can stretch the details, but apart of that, that's all of the options. Okay, we have our outline, which we want to generate the wire path. We're going to a cam module, and the color of the lines just change. There is a little red line showing a start point. That's where the will be moved in the material, but that's from a start, and the start is always 0, 0 for a wire cam. For a wire plotter, of course, you can just tell the start will be somewhere else, for example here in a material, yeah, or out of the material. Like I said, for a program, it's just a point in a virtual space. I mean, you can just offset your machine and tell the machine to start from that point. Yeah. Anyway, that's the start. That's the select first option. Of course, algorithm automatically on the start detect the closest point on the outline, and it just generates, we want to start from this point. But if we want, for example, start from somewhere here, which is the tip of the horn, we're just selecting that point here. We're telling that start point will be on the edge here, and at this moment machine on the start need to move, or you need to manually move to that point and offset the machine, or machine will generate the move from 0, 0, which is your and mine home point, to that point here. Then it will move into a material and start cutting. Okay, that means we have the first point, we have the start point on the line, and we can just generate some end point. Okay, that will be it. All right, yeah. As you see, this outline is not only one single long loop line. There is other loop line here, other loop line here, and other loop line here. And algorithm, when we'll be generating a path, it automatically will pick up the closest point between two loops, and then it will generate bridge. We can just add a jump junction that means the bridge, clicking manually here, and we can just select, for example, I want that from start here to here, and the same here. I didn't want the closest point, I want algorithm to just pick this point and go to this point. Okay, and this part, algorithm will detect its own where to go to the cut, where to go over the material, because wire cutter is a very specific machine, because the wire cannot be retracted from the machine because it's straight between two points. That means it's always in a material, and it's not possible to just go into that line and just cut that out without cutting somewhere over the material. That means at this moment, algorithm in this point will just pick up some point and create a jump. Okay, when we select everything which we want to select, we're clicking a simple calculate wire path, and at this moment algorithm just calculating the path of the wire. It's showing that, doing that crazy moving of the wire, and that's it. We have the our job. We can just save the G-code here. We can just simulate the G-code, or we can just send it directly to the machine. When we connect the USB cable from the computer to the machine, we can just connect to the controller and send it directly. Okay, let's simulate. There is option at this moment available, simulate, and when we click that, we can see the speed of the wire in the material and how it will move. Okay, we can just, of course, speed that process up. And go to 0, and that will be it. This project have just 5,640 lines, and that's it. We can save this outline, and it will be saved as some, oh, not here, sorry. Okay,